Hi, this video will be about Avalanche blockchain platform. Okay, let's start, guys. Avalanche is a decentralized open source proof of stake blockchain with smart contract functionality. AVAX is the native cryptocurrency of the platform. Avalanche started off as a protocol for solving consensus in a network of unreliable machines where features may be crash, fault, or Byzantine. The protocol's fundamentals were first shared on interplanetary file system in May 2018 by a pseudonymous group of Ethereum going by the name Team Rocket. It was later developed by a dedicated team of researchers from the Cornell University. The research was led by Emin Gun-Cyrus, a professor of computer science and a software engineer, assisted by Dr. Students Malfan, Ted, Ian, and Kevin Sekin. Following the research stage, a startup technology company was founded to develop a blockchain network that would meet complex finance industry requirements. As a number of sources indicate, the project was in the realm of academic circles interested in exploring consensus protocols that serve the same purpose of proof of work. Securing transactions are more energy efficient and have the potential to provide a basic for democratic development and the inclusion of more users in consensus process. In March 2020, the AVE codebase developer accelerator program of AVE DEP for the Avalanche consensus protocol became open source and available to public. In September 2020, the company also issued its native token AVAX, an acronym for Avalanche. The Avalanche token is traded on the exchange. The protocol has four basic integrated mechanisms that compose structural support of the concession tool. These four mechanisms are slash, snowflake, snowball, and avalanche. By using randomized sampling and metastability to certain and persist transaction, it represents a new protocol family. Although the original paper focused on a single protocol, namely Avalanche, its implicitly introduced a broad spectrum of voting-based or quorum-based consensus protocols, called the Snow family. While Avalanche is a single instantiation, the Snow family seems to be able to generalize all quorum-based voting protocols for replica control. Unlike prior quorum-based vote, the Snow family enables arbitrarily parameterizable feature probably at the quorum intersection level. Standard quorum-based protocols define this feature probably to be precisely zero, but by introducing errors in the quorum intersection, a larger set of consensus protocol design is available. What about background? Consensus protocols are basis for the state matching replication problem, which aims to enable a set of machines to achieve agreement over a network even when a subset of the machines are corrupted. There are two major families of consensus protocol to date. The first is classical consensus and second Nakamoto consensus protocols. And the first achieves consensus through quorums, thus recurs voting. Famous instances of this are Paxos in the crash fault tolerant environment and in the Byzantine fault tolerant case. These protocols achieve agreement in a similar operation to a parliament. A proposal, the transcription, is proposed and voted on the accepted or rejected way. If sufficient votes cast by the various replicas are accumulated, typically collected through elected leader replica. Then a quorum is achieved and thus agreement. The second family, pioneered by Satoshi Nakamoto and Bitcoin, is that a Nakamoto consensus. Unlike quorum-based protocols, machines operating off instance of Nakamoto consensus achieve agreement on transaction by doubling the longest chain, typically called a fork. In Bitcoin, the longest chain is verified by ensuring that it is the one with the highest degree of work, or proof of work. Snow, while quorum-based, seems to be an universal generalization of all quorum-based protocols. Unlike prior works, which occurs that quorums be deterministic, and also the feature probably is precisely zero. Avalanche loosens these requirements, thus enabling quorum-based protocol to estimate global network state with euros. While the Snow family can be theoretically generated to a classes of assumptions that quorum-based protocols have previously made, the formalization paper analyzes Avalanche under an asynchronous network in the Byzantine setting. The assumptions are as follows. Processor operate at arbitrary speed. Processor may experience arbitrary failure even Byzantine ones. Processors with stable storage may rejoin the protocol after failures. Processor can collude, lie, or otherwise attempt to subvert the protocol. Okay, it's all for now, guys. Goodbye.